Good morning. I'm going to teach you the decision tree algorithm. A decision tree is a graphical representation for finding all possible solutions to a problem or decision based on the given conditions. It is called a decision tree because similar to the tree, it starts from the root node and further go to the branches and then subtree and all. To build a decision tree, different algorithms can be used based upon the problem and the given data set. Popular algorithms include ID3, C4.5, CART, and random forest. Among them, CART algorithm is widely used. Decision tree terminologies: root node, that is the topmost node. From that only the branches start to split. So from the root node, if you are taking a dividing into two parts, that is called as a splitting, that leads towards the subnodes. And branch or subtree from the root node, if again some nodes we are going to connect, from that will be leading us a root node for the further process, so that is called as a subtree. Leaf node, the final output node of the decision tree, is called as a leaf node. Parent and child node, the root node or any node that gets divided is called as a parent node, and the resultant node is called as a child node. Pruning, the process of removing unnecessary branches from the decision tree to reduce the complexity and avoiding the overfitting, is called as the process pruning. This is the sample example for the decision tree. So the first topmost is root node. From that we are going to make a classification. So it is representing the age. So obviously the age we are classifying less than 18, 18 to 30, above 30 to find out the heart risk. To get the heart attack, how much risk we are having in the particular age. So here, so the first one is root node. This is called as a splitting. This is called as a subtree. So based upon the smoking habit, we are having a risk or not. Like that we are splitting. So final we are deciding whether it is a low risk or high risk, which is called as here the final node. That is called as a leaf node. Final node is called as a leaf node. Likewise, we have to split and we have to take a decision. With the help of the tree structure is called as a decision tree. The steps to build a decision tree. First, we have to start with the root node, which contains entire data set. Then we have to select the best attribute from the data set using the attribute selection measure, which is ASM, such as Gini index, entropy, or information gain. Then split the data set S into subsets based on the possible values of the best attributes. Then the next step, we have to generate the decision node that represents the best attributes. Then repeat the step 2 to 4 recursively on each subset until further classification is not possible. So at this stage, final nodes are called leaf node, which represents the outcome of the decision. So attribute selection measures for the decision tree. There are two widely used techniques are there. One is information gain, another one is Gini index. So for the information gain, first we will be calculating the entropy. The formula for the entropy is H of S is equal to minus summation of Pi log base to Pi. Then for the information gain calculation, the formula is H of S minus summation of SV by S into H of SV. So SV is the subset of S where the attribute A has a value of V. Then the other method is Gini index. It measures the purity and impurity of the data set. If Gini index is high, then which indicates the more impurity. If Gini index is low, which indicates more purity, that is high purity. The formula for the Gini index is Gini of S is equal to 1 minus summation of Pi square. P is the probability of choosing an element of the class I. ID3 algorithm. ID3 is an algorithm used in machine learning to construct decision tree from the data set. The algorithm follows a top-down recursive approach where it is repeatedly selects the feature that provides the high information gain to split the data set. ID3 relies on the concept from information theory, mainly entropy and information gain, to decide which feature should be chosen at each step of the tree construction. ID3 steps. The first step, we need to calculate the information gain for all features. If no row belongs to, all the rows are there which are all not belongs to the same class, then split the data set into subset using the feature with the maximum information gain. Create a decision tree node using the feature with the maximum information gain. Next, if all rows belongs to the same class, then make the current node a leaf node with the class as a label. Repeat the process for remaining features until either all features are used up or all nodes become as a leaf node. So here is the problem. They have been given the 6 instances in the data set, that is 6 samples in the data set, and the classification, they have been classified like a positive or negative classification. Then A1, A2, two types of features they have been mentioned. Okay, so for the first feature, the classification is positive, so it leads the true, like the true or false they have been mentioned for both the features. So now we need to calculate the entropy, then information gain. From the information gain value, we have to choose one for the subnode or else leaf node. The first attribute A1 we are going to take. So anyway, for the classification, totally we have 3 positive, 3 negative. So the overall is entropy S, which has 3 positive and 3 negative. So if you are applying this in the entropy formula, we will be having an entropy value as here 1, because 3 positive and 3 negative equally distributed. So value is 1. Next we are going to calculate for true. So only we have been chosen the attribute A1. For that A1, first we have been check the classification. So 3 positive, 3 negative, we have been found the entropy. Now in that A1 attribute, total 2 outcomes we are having. One is true, another one is false. So first we have to calculate the entropy for true, then we have to calculate the entropy for false. So for the true, again we are having a classification like 2 positive and 1 negative. So entropy for the true part for the attribute A1. So 2 is positive, 1 is negative. So the entropy formula minus 2 by 3 log base to 2 by 3 minus 1 by 3 log base to 1 by 3. So this 2 is representing 2 positive, this 1 is representing 1 negative. So applying in the formula, we have been calculated the value as 0.9183. The same way we are going to make a calculation for the false. So for the false, total 3 false we are having. Out of the 3 false, 1 is positive, 2 is negative. So 1 is positive, so 1 by 3 log base to 1 by 3 with help of minus. Again 2 negatives we got, so minus 2 by 3 log these to 2 by 3. After calculating, we got the same value. Now, the gain, we have to calculate, information gain, we have to calculate, we know the formula already. The entropy minus summation of SV by S, entropy of SV. So, the overall entropy we calculated as here 1, that we can substitute in this place. Here, if you are extracting the summation, we will be having here overall SV is here 3 positive we got, 3 negative we got. So 3 out of 6 and same 3 out of 6. So 3 by 6 entropy for true is 0.9183. So that we are going to apply over here. The same way here also for the negative, again 3 out of 6. So entropy for the false is 0.9183. So the formula is for information gain of A1 attribute, entropy, overall entropy minus for true prediction, we have here positive 3, then the overall data set is 6. So entropy 1, overall entropy 1 we will be substituting, then 3 by 6, the entropy for the ST we calculated, then same 3 by 6 and entropy for SF we have been calculated, we have been substituted here. Next we are going to calculate for the attribute 2. So again for the attribute to the overall entropy with the classification 3 positive 3 negative. So the answer is 1. Next, for the particular attribute 2 alone we are going to calculate the true and false. So if you are looking for the attribute 2, we are having a true as a 4 and false as a 2. So first we will be calculating for the true. So total 4 true are there. In that 4 true, 2 is positive classification, 2 is negative classification. So 2 positive, 2 negative, 2 negative. So again for the same, the entropy will be leads the value 1 as a result. Then for false category, again 1 positive, 1 negative. So 1 positive, 1 negative. The answer is 1. Now we are going to calculate the overall information gain for the attribute 2. The formula is here. Then if you are expanding entropy, overall entropy S, then for the attribute 2, totally we got 4 true. So 4 out of 6. Then true we have been done, false 2 false out of 6. So this is for true category. This is for false category. So for the true category, 4 out of 6. Then the entropy we calculated is 1. Then for the false category, 2 out of 6. The entropy we calculated is 1. If you are substituting all the values, it leads the result as a 0. Now, we have been calculated the information gain for both the features. One is attribute 1, another one is attribute 2. So here the maximum gain we can see easily for attribute 1 only we have been achieved. So we have to choose A1 as a root node. So initially from the data set, we don't know what will be the parent node. We can choose A1 or A2, but if you are choosing like that, okay, it will be leading a different results. Then it may mainly lead the increase in the steps. Actually, the algorithm will be efficient if it is reducing the number of steps. Easily if you are getting the result with reduced number of steps. So for that purpose only we have been used this ASM, and then we found the information gain value. From that information gain value we have been chosen this as a maximum gain. So we are choosing this as a parent node. So A1 is the parent node now. So A1 is the parent node. So from the A1 we have the two results. One is true, another one is false. So true, false, like that we are splitting from the root node. Next, if you are splitting like that, the 1, 2, 3 will be coming under here, and 4, 5, 6 will be coming under here, under the false category, under the true category. Then the next attribute A2 we are going to take for each